In this episode, we're going to talk about tags, and this is the third episode in the introduction to this manual, Machine Level HMI with Ignition, integrating SCADA software into the PLC learning path. And in this manual, we're going to, side by side with the PLC learning, introduce you to HMI software. This manual is available to order as of August 2025. So it is available to order at the release of this video. I only order a limited amount because I don't know what the demand is going to be. So depending on when you order it, you might have to wait 2 weeks if the inventory is already gone. We're going to begin the third episode of this series talking about tag names, also known as pointers, variables, registers, a variety of names over the years for memory locations. Actual memory locations have numerical matrix, row 0, bit 0 through whatever the limit is of the memory. It's numerical allocations, but that's not what we work with. We work with variables. Some are predefined, some you create. We're going to talk with the oldest platform of the three. So you see on my screen here, this is Micro 800 with Connected Components Workbench. That's the newest of the three platforms. This is the oldest. And this is Micro Starter, which is basically a stripped down version of Slick 500. This software would represent Ethernet redundant with motion. We have these three platforms that we're going to talk about variables. I'm going to start with the oldest one. And in the oldest one over here, you see data files. And under data files, never mind the cross-reference, that's a placeholder for cross-reference information. And clicking on it doesn't give you a whole lot. We're going to talk about files 0, 1, 2, 3, 4, 5, 6, 7, and 8. These are all pre-declared variables. If I look at output or input, and I can go to input down here by just clicking, see that's file 0, file 1, inputs and outputs. These are all basically integers, 16-bit, and these are the, if you want to call it the tag names, I:0.0 bit. The format for memory in a Slick 500 or a CompactLogix is I for the file designation, a delimiter of a colon, then files word 0, and then this is bit 0, bit 1, bit 2, and so forth. The output, file 0, has the exact same format. Those are pre-declared variables, but they're hardware dependent. In other words, you can't expand these unless you add add-on I/O. In other words, if you add an I/O module, then you can actually expand the size of these two files. But for right now, we just leave it the default. Here are two files, and these are the tag names, I:0.0/0, 1, 2, 3, 4, 5, 6, 7 through 15. Status is a unique set of tag names, and this is the structured format. You can actually access a lot of these tags in the CompactLogix 1400. If I change it to decimal, now you just see the values that are in those tags, S5, S4 time base. You can see the free running clock. It's unlikely you're going to be accessing any of the tags in S2 status, but you will B3. This is a predefined array, single element. Technically it's an integer, but we treat it as a bit. We address it to the bit level. The file is B3, word 0, bit 0 through 15. When we get to tag names in Ignition, if you want to access one of these bits, you have to use B3:0/8 for that bit. You can't give it a man readable. Now there is something called a symbol, which you can type in here, and you could give that a name. Let's say that bit is on for a rotate. But that word rotate will not be accessible in Ignition. You're going to be grabbing tags out of the 1400, MicroLogix 1400 or Select 500 at the word and bit level. Same thing with timers. You got a single element array. It's one single element, T40. Now you can go to properties and you can make it any number that you want up to 256 total. Now I can't do that online. I cannot change the data table online, and I'm online right now. T4:0.en or /en/tt, timer timing /dn done. Those are all accessible, including the preset, which is going to be an integer, and the accumulate value, which is an integer. You can grab any of these tags to bring into Ignition, but this is exactly what they're going to look like. There are no man readables. Same thing all the way down here for counters, control. These are used for sequencers and other types of data files that need manipulation. This isn't part of this course. And then integers look a lot like the B3 file. We're displaying it as a decimal, but it can be displayed as binary, which means you can address it right down to the bit level. B3 and N7 have very similar behaviors, but the tags that you're going to access in Ignition to control the appearance on the screen of states in the PLC, this is what the tags are going to look like. There are no main readables. Same thing with floating point. And notice that you cannot display floating point as anything else but floating point. You can't change it to Boolean or integer or any other structure. That's the basic tag structure for, we'll call it the Select 500 MicroLogix family. We'll drop that out of there, and then we'll go to 5000, which really is probably the most powerful of all the platforms for Rockwell automation. And if I go into the controller tags, now remember this, the project for the MicroLogix 1400, which I just minimized, this is a project that I created an instance of a MicroLogix 1400. You go to controller properties here, and you can see it's a MicroLogix 1400 Series B. I created an instance of MicroStarter, and I named it up here Ignition 00. But I've done nothing else. And I downloaded it as a raw program file to the controller. So what you're looking at is what you get without adding anything. Okay, you get these tag names, and you can expand these out to 256 elements in each of these arrays. Now in 5000, you also have some predefined variables, and we would go to the controller tags to see those. You can see these are all I/O. This particular L27ERM QBFC1B has 4 modules built into it, more or less. It's got inputs, outputs, and it's got high-speed counters and analog. These are the 3 modules, 1, 2, and 3. And for module 1, this is data. This would be your actual I/O. Okay, it's basically an IQ16, I/O module. It's 16 bits of input. A controller, not a processor. It has I/O built right into the plastic package. Without adding anything to this program, these are all the tags that you have access to, including analog channels, inputs and outputs. These are the tags that you have access to add into your Ignition Vision project. Then we have the Micro 800, and if I go to Global Variables, that's where I'm going to find all the I/O. You see, I have the tags predefined because they're hardware fixed. I/O embedded digital input 00 through 13. I have 14 digital inputs built into this controller. It's an 850E. And then I have 0 through 9, which is 10 digital outputs. And that's it. These are all system tags. It doesn't matter what hardware platform you use. Once you get used to the idea of tag names It's all the same. As long as you can add a device connection, and you would do that here under config. And of course, I'm going to have to sign in, which this is kind of a nuisance, but as long as you're using the free version, you'll be doing this a lot. Create a new device connection. Now you can see that I've already got a whole bunch of connections configured. There's the L27 ERM at this IP address, a micro 850E at this IP address, a CompactLogix 1400 at this IP address. I've already set up, and you will do this later in the manual. We're just kind of giving you a jump in, quick look ahead. Later in the manual, you will actually configure these device connections. And in the tag browser in Ignition Vision, when you want to add a tag, you will actually pick one of these paths into one of the three controllers to grab a tag. That was a look at the tags or variables, pointers that are available in these three platforms with a raw, untouched project that you created, but you've not done any modification. You've not added any tags, you've not added any logic. Now looking at the oldest platform, which would be Slick 500 CompactLogix, remember I pointed out that these are single element arrays. So each one of these is an array. So if I go to B3 and open that up, I see one word. I'm going to change this to decimal for the radix. So you can see B3, 0, and there's just one word, B3 : 0, and the value is 0. So I'll change it back to binary because we think of it in terms of bits. So if I go to properties and put in 3, apply, now I've got 3 16-bit words. I did not create any new tags. Not really. I expanded the B3 file from one element to 3. And you can do that with all of these single element arrays here in this platform. I just call it 500, or CompactLogix 500 MicroStarter. CCW, you can go in and besides the IO tags that we talked about before, I can expand those IO tags, and there aren't any other tags to expand. So I can actually create a tag, and I'll call that Monkey Doodles, and I can make it any data type I want, any of these. But we'll make it a real. So I'm going to type in RE. There's real, which you might consider floating point. So I can go into Connected Components Workbench for the Micro 800, and I can create all the tags that I want. Plus I have the IO tags that were already there. And when we look at 5000, here's the IO tags. But I can go in and create a new tag and call it Monkey Doodles. I could make it the same thing I made it in the other, but just for grins, I'm going to make it a double integer, and I'm going to make it a single dimension array of 10. So that means it's going to be Monkey Doodles .0 through 9. Or I can make it a 10 by 10, which would be a 2-dimension 10 by 10 or 100 double integers. And I can go another one, 10. So now I have 10 by 10 by 10. So I have 10 rows, 10 columns, and 10 roots, or it's a 3-dimensional thing. So it's 10 by 10 by 10. So that is 1,000 double integers in a 3-dimensional array, 10 by 10 by 10. The point is I can go in and create tags in 2 of these platforms, call them anything I want, making any kind of data type I want. Now, my first bit is one that you're going to do in your lab projects. That's going to be a Boolean. So if I type in B, bool comes up. Now I've got a tag. It's not a predefined tag. Neither of these tags are predefined in 5000 or in CCW, but all the tags in 500 are predefined. So this is what you're going to be doing throughout this course is you're going to be accessing tags out of logic that you've created to bring the data into Ignition Vision. Thank you.